Hello and welcome to our very first ever AP Physics 1 video. My name is Mr. Sohn. Let's get into it. We got Unit 1 for AP Physics involving kinematics. Now, kinematics is the study of motion, how things are moving. And when you're talking about motion, you're talking about objects, how big they are, and how fast they're going. Now, one thing that you have to break yourself of is there's a difference between just speed and also speed with direction, and that's the main difference between vectors and scalars. So vectors are something that have not only speed, but they also have direction. Okay? And speed is typically thought of as, with vectors, a magnitude. Okay? A magnitude and a direction. Okay, so if they have a magnitude and if they have a direction, that would be considered a vector quantity. A scalar quantity is only going to have the magnitude, meaning it is only going to be involving speed. Later on, you'll think of it as mass or temperature and so on and so forth. Okay, but for right now, you should really just thinking scalar quantity is speed. Okay, and a example of a vector would be velocity, both of which are a representation of speed, but velocity not only tells you your speed, but it also tells you the direction in which something is going. Later on, you'll think of it as displacement. Well, pretty soon we'll think of it as displacement, but later on you'll think of it as force as well. Okay? All of this is revolving around the idea of position. So position is where you are in relationship to it. So in the beginning, we're going to be focusing on one-dimensional, which would be a simple like left-right idea or a simple up-down idea, and it refers to the x dimensions, and it would be positive would be to the right, would be going to the right, whereas negative would be to the left, like normal mathematical practices, you know? And if it were 2D, then you have an XY scale where you actually involve the vertical and the horizontal. And just like you would think, it would be combining both, and you would have an X and a Y quantity, and normal math practices would fall into place where up and down and left and right would be in place at the same exact time, and that would be later on. But it's still involving position. Now, there is a big difference between displacement versus distance. Now, all of these are going to be showing you the vector idea on the left and the scalar idea on the right. Whereas displacement, this is whenever you're thinking about it. So like, let's say we were starting here in the middle, and we can call that 0. And I went to the right for a little while. Let's say I went to the right by 2 miles, even though with physics we tend to talk about meters. But I'm trying to keep it with things that, let's say you walked 2 miles to one store, and then you walked back over to here, and you had to walk to this store over here 1 mile away from our original over here. How far did we actually go versus how far have we actually been displaced from the center? So even though we went 2 miles to the right, and then we had to go back 2 miles, and then another mile over here, even though we've traveled a distance that is much further, we're currently over here at store number 2, which is 1 mile to the left. It is displaced by 1 mile, and we would call that negative 1 mile because we are left by 1 mile compared to where we were before. That is much different than distance, because if we think about the distance that we actually traveled, well, if we went 2 miles to the right, then we would have to go 2 miles to the left, and then we would have to go another mile to the left. We would have actually traveled a distance of 5 miles. And distance is referring to how far you actually have traveled, okay? How far you actually traveled versus displacement is the change, or delta. You'll see this triangle symbol a lot. The change in position, which you can find by taking your final position not delta finite, final position, and subtracting your initial position. Okay, so you could take your PF minus your PI. I don't know why I did this F. I started saying final and then I wrote the letter F. So take your final position and then subtract your initial position, and you'd be able to get your change in position, which in this situation, we started at 0, and then we moved to the -1 to the left, so we took -1 minus 0, that's -1. Okay? Velocity is going to be telling us the same sort of thing. So velocity is going to be able to tell us how fast something is changing, and it is in relationship to position. So velocity would tell us how fast something has changed in position and over how long of a period of time. Now, that is very similar to your distance equals rate times time formula that you've probably heard of a few different times, but that is different than speed because speed is involving distance. And if we just learned something about here is distance is not necessarily displacement. Distance is how far you actually traveled. So that's why we have here the change in x over the change in time versus speed is going to involve distance equals rate times time. Well, if we wanted to solve for rate here, it would be the distance, the overall distance divided by your time would equal your actual speed. Now, speed will be positive, but your velocity could be negative. If you're going down or if you're going to the left, that would indicate that you're traveling at a rate that is going in a negative direction, and therefore it would be considered negative. All right? So, we got one example, and then we're going to probably call it for the day. We got Mario drives a go-kart around a circular track with a radius of 20 meters. What is his displacement and his distance traveled? Okay, so let's think about this for a second. So here's Mario. Hey, he is on a circle. Here's Mario. And he has got a radius of 20 meters. So label Mario over here. As he's traveling around this track, it's a circle. So as he is traveling around the track, what is actually happening? Well, in the beginning, he is going up. And this would be considered 2D because he's not only going up, but he's also going to the left. So that would be 2D. So his velocity is going and doing something, but we're really talking about displacement, not velocity here. So he is moving currently away from his current position. But after he finishes the circle, what actually happens? Okay, so if he finishes the circle, then we would have traveled 0 in displacement after he's finished the circle. So upon completion, his displacement would be 0. What would his total distance traveled be? Well, his total distance would be 2 pi r because he would have traveled around this circle. So if we did 2 pi times 20, his distance traveled would be 40 pi meters, which is very different than displacement. So, example B. I want to do another example. Let's do another example. Under what conditions will an object have a distance equal to its displacement? Well, let's think about that. If we are trying to get the distance to equal displacement, we, for starters, probably not travel in circles. The other thing that would have to happen is we would probably not be able to do what we did over here, which is go forwards and backwards and backwards and forwards. And last but not least, we would need the displacement to be positive because distance is always going to be positive. You're not going to travel a negative distance. You can travel a negative displacement because you can go backwards, but distance is going to be positive no matter what. So you would need to be either A, only traveling in the right direction, or B, only be traveling in the upwards direction. Now, normally, we're going to be talking about, for the beginning, going on the ground. So I would say, under what condition? Well, it would have to be going the same distance and displacement to the right direction or upwards, because if we went to the left, the displacement wouldn't be the same number, but it would be negative. So both would have to be traveling to the right or up. So both traveling to the right or up. And I guess you could make the argument that you could also be traveling both the same up and to the right. All right? Let's do the last one before we get to acceleration, which is going to be a different video. Pikachu and Eevee, Eevee? I don't know Pokemons, are both located at the origin. At a time of 0, they both start moving. Pikachu moves at a velocity of 20 meters per second. Eve moves at a velocity of negative 10 meters per second. Find the distance between the two after the 10 seconds. So both of these are considered vector quantities, and therefore the direction matters. That's the whole idea of vectors, is so that we know that where things are going. Well, we know that Pikachu is moving 20 meters per second, assuming he's moving on the ground. So he is moving 20 meters per second to the right. That would be Pikachu. And then we have Eevee, who is moving a velocity of negative 10 meters per second, and that would be to the left. So that would be to the left at negative 10 meters per second. Well, how far are they after 10 seconds? Well, using the formula, distance equals rate times time, which we are going to adapt in a very future video, like very near. But basically, the displacement can be replaced in this way as well. So how far have each of them traveled? Well, we have the rate of negative 10 times 10 seconds, and we have the rate of 20 times 10 seconds, which would give us negative 100 meters for Eve, and it would give us 200 meters for Pikachu. So if he has traveled 200 meters, not meters per second anymore, and Eve has traveled 100 meters to the left, how far apart are they? Well, you would just find the actual distance between these two, and you would find out that they are 300 meters apart. That's going to do it for this one. Until next time, everybody, stay positive, and I will see y'all later. Bye.